I'll wait for next year.
Okay. The particle model of EMR. So now we're in the second half of EMR. Actually, we're talking about the second part of the theory, but we're kind of more than halfway through this unit, so that's positive. So, back to Planck. He suggested there is a minimum amount of energy that an EMR with a particular frequency can transfer to matter. So this smallest individual piece of energy that can be transferred to matter from an EMR is called a quantum. Therefore, a quantum, so how much, think about light, when it hits, say, a wall or something, how much energy does the wall absorb from the light? Well, that's in form of a quantum. So a quantum, then, we can say is a discrete, meaning like we can measure it, so a discrete amount of energy. Quanta is the plural of quantum, so just FYI. So therefore, particle theory in physics, we say really that's quantum physics. So it's equivalent to quantum physics. So when people talk about quantum physics, it means the particle theory of EMR. Okay? So Planck was saying that energy is not continuous, but instead is quantized, coming in tiny discrete pieces or amounts, pieces / amounts / packets. So it's the way that you think about it is instead of the light just being like one beam of energy, it's like bing, 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 like lots of little packets of energy being emitted. Okay? So Planck's theory can be compared to a digital picture. A digital picture appears to be one continuous picture. It appears to be, but really it's made of pixels, so little packets, okay, or like little pieces or packets. Just kind of like how energy from EMR is like little packets, but it appears to be continuous energy. Planck's idea of energy being quantized applied to how matter absorbed and emitted energy. Okay? But it was Albert Einstein who extended this idea to explain certain EMR behaviors and properties. Einstein suggested that all EMR was made up of individual pieces that contained specific amounts of energy, i.e. that the EMR spectrum was quantized. This means that EMR was acting like a particle. Particles of EMR with a discrete amount of energy are called photons. Okay, super important definition here. Okay? Particles of EMR with this discrete amount of energy are called a photon. Okay, so that's where photon comes from. Planck found that a very simple formula could be used to calculate the amount of quantum based on the frequency of EMR. This is the same as calculating the energy of a single photon. So quantum, singular, single photon. So this formula is only for one photon. Very, very, very important that you remember that. Single photon. Okay? So you assume that this formula is for a single photon. So E stands for energy. It's in joules or EV. So that's electron volts. And when you're trying to find, if you want to convert between joules or EV, go to your data sheet and see Here, electron volt, 1 eV, is equal to 1.6 times 10 to the negative 19 joules. So remember to convert back and forth between those. That's what you do. But you can give your answer in either. And it kind of depends what you use, which one you'll answer in. F is frequency, it's hertz, or it's like 1 divided by seconds, or seconds to the power of negative 1. H is Planck's constant. So this is a new one, and it is in your data sheet as well. So you can see Planck's constant, and it gives you 2 units, either in joule times seconds or EV times seconds. So depending, you'll use different ones depending on what formula you're using and what other variables you're using in that formula. So be mindful of that. And I'll show you a couple examples. C is the speed of light. So remember, look here where it says speed of light in a vacuum. C is equal to 3 times 10 to the 8. And lambda is your wavelength. This formula is the amount of energy emitted by a single piece or a quantum. To have multiple pieces or quanta, the formula would look like this. E is equal to N times HF, where N is the number, okay, where N is equal to the number of photons. Okay, so if you're given the energy of multiple photons, then you need to think about your formula like this, where you have N times by H and F. Notice how the equation for a photon is still linked to wave properties. Therefore, a new theory was starting to develop that explained that EMR was both acting as a wave and a particle simultaneously. This is known as the wave-particle duality, which if you look on your data sheet, okay, looking on your data sheet, it is number 9 on physics principles. If you're asked questions that involve both light and wave properties, particle and wave-like properties of EMR, that is principle 9. So let's do a couple examples.